Today on Capecchi's Corner, we're going to look at arcs and chords. Our first theorem for today says in the same circle or in congruent circles, we know two things. Number one, congruent chords have congruent arcs, and we also know that congruent arcs have congruent chords. Now we know the circles are congruent because they each have a radii of 5. So therefore, when we're comparing, we know this is 145 degrees, this arc, and this is 145 degrees. So because these arcs are congruent, we know that the chords are congruent. So I can say that this chord is 8, so therefore this chord is 8, so x has a value of 8. I can do the same thing and looking at the top of that circle there. I have, again, another arc there that's 120 with a chord that's 7. I also have a chord on this other circle that has a measurement of 7. So I know that this arc Y, has to be 120 degrees. Our next theorem for today says that a diameter or radius that is perpendicular to a chord bisects the chord and the arc. Right here we have a radius, and it's perpendicular to a chord, so we know that that chord is bisected. So if this is 6, we know that x has a value of 6. Now we're going to build on what we just did in the previous theorem. This whole chord now has a measurement of 12. This right here has a measurement of 12. This chord right here has a measurement of 12. So I know the arcs have to be congruent. So this is 140. This whole arc there also has to be 140. But if you look at our theorem, it says this diameter or radius that's perpendicular to a chord bisects the chord and the arc. So if this whole thing is 140, and there's my perpendicular on the chord, I know y is going to be half of that. So y is equal to 70 degrees. In our next example, we're asked to find the measure of AB. So I have a radius of 10. So I know this piece is also 10 because that's a radius. This small piece right there is 4. So I'm going to make that 6 there. I also have a radius here which is 10. Now if I use Pythagorean theorem, or it's actually a triple, so I have a 6 and then I know this piece right here is 8. So therefore again, now I notice that this chord right here, AB is a chord, and we realize that that chord meets the radius at a 90-degree angle. It's perpendicular, so I know the other part of that chord is also 8, since that radius splits the chord in half. So therefore my measurement of AB, that entire chord, is 16. Our next theorem states in the same circle or in congruent circles, two things occur. Number one, chords equally distant from the center or centers are congruent. And the converse of that, congruent chords are equally distant from the center or centers. So in our first example, I notice from the center to this chord has a measurement of 3. From the center to this chord also has a measurement of 3. So that means the chords are congruent, so x has a value of 14. In our other diagram, we have two congruent chords. This chord is 10, this chord is 10, which means that they are equally distant from the center. So since this has a value from the center to that chord of 5, we also know the same is true. From the center to the chord is also 5, so y has a value of 5. In our final examples for today, we're going to look at combining a lot of things that we've talked about so far in this circles chapter. It says in each diagram, point O is the center of the circle. So in our first example, we're looking for a measurement of RT. And I notice that RT is a chord, and it's perpendicular to the radius. So that's going to mean that the chord is divided in half. So that makes the measurement for RM to be 15. So RT is equal to 30. Now, in looking at OM, I realize I have a right triangle on the right-hand side of this circle right here. So I can use Pythagorean theorem, or it happens to be a triple. So I know that OM has a value of 8. And looking at our last example, I realize that I have a major arc here of 220, which means this other part of the circle, that arc right there, is going to have a measurement of 140, since the total degrees in a circle is 360. So that minor arc AB, is going to have a measure of 140. I also realize that I have a chord here, and it's perpendicular to the radius, so I know that that's going to be divided into 2. Since the chord and the arc is divided in half, is bisected, so that makes each measure of the angle to be worth 70 degrees, so the measure of angle AOC is 70.